In this video, we will discuss TVS diodes for surge protection, looking at a few critical specifications that determine whether a TVS diode will provide robust surge protection. If you don't have a background in the fundamentals of TVS diodes, please take this time to watch TI's ESD Essential video series before you complete this video. You can access the ESD Essentials video series by clicking the animation below. TVS diodes for surge protection have the same behavior as for ESD protection. However, because the pulse energy that must be absorbed in a surge is much larger, some specifications become more important. This video will focus on the aspects of TVS diodes that are more relevant for surge protection. The purpose of an input TVS diode is to shunt excess current to ground during a surge. The TVS diode should ideally be invisible to the system during normal operation and then immediately clamp the input voltage at the breakdown voltage during a fault. But unfortunately, all diodes have non-ideal limitations that must be accounted for. The first important limitation is the max surge current, or IPP. This specification defines the maximum amount of current that the diode can absorb before it will overheat and break. The current that a TVS diode can sustain depends on the length of the current pulse, so IPP is always defined reference to a characteristic waveform. Sometimes this reference waveform is the 20 microsecond waveform defined in IEC 61000-4-5, but more commonly it's a 1000 microsecond waveform used for specifying TVS diodes. When designing, make sure that a diode IPP is higher than the surge current that must be withstood per the IEC 61000-4-5 tests, and that the surge current is in reference to the same waveform you are testing with. The second important limitation is the TVS clamping voltage. Non-ideal diodes can be modeled as a dynamic resistance, or R-dyne, in series with a breakdown voltage, or VBR. This means that when current flows through the TVS, the measured voltage can rise significantly above the diode breakdown voltage. This voltage is determined by R-dyne and is called V-clamp. V-clamp depends on the current through the TVS, so will always be defined relative to a surge current. V-clamp is the voltage that will be seen by a system during a surge pulse. So even if the diode breaks down well below system tolerance requirements, if the V-clamp is above your IC input absolute maximum, the input of a system can see failures. TVS diode datasheets have a V-clamp specification, again in reference to a specific waveform and pulse current. The best practice is to make sure that V-clamp is less than the absolute maximum voltage tolerance of your input circuitry. It's important to understand these limitations and select TVS diodes that will robustly protect a system as pulse energy increases. Properly selected peak pulse current and clamping voltage are what make a surge protection stage robust. Even with these limitations understood, there are a few other commonly made mistakes, which we will discuss in the next video in this series. Thank you for watching.